Now, quick question with your clicker. What kind of friction is desired between your car tires and the road, assuming it's August and the roads are dry? Do you want kinetic friction, static friction, or both? What do you think? Okay, last call. The answer is B, static friction. Okay? Now, I made two assumptions in writing this problem. First, I've assumed that you are not a 16-year-old male, that when you go down the street you don't squeal your tires at every opportunity. Okay? When you're squealing your tires spinning out, that's kinetic friction, and you can hear it. Okay? Now the same thing is happening on your wheel. It's just happening on a smaller part of the wheel, right there at the bottom. There should be no motion between the rubber at the bottom of your tire and the road. Those nooks and crannies should be firmly enmeshed together if you're not screeching out. Now, I said I made two assumptions. The one assumption is that you're not a 16-year-old male. The second assumption is that your parents love you. Okay? And here's how you can tell if your parents love you. On a very icy day, which happens in Bozeman a lot, just get going about 25 miles an hour and then just slam on the brakes. And if your wheels lock and you start sliding, you need to have a heart-to-heart with your parents and ask, why don't you love me? What is it? If, on the other hand, you hit the brakes and you hear a machine gun go off, that is the sound of love. That is the sound of love. What is that sound? The machine gun going off. What is it? Anti-lock brakes. Okay? Anti-lock brakes. It turns out that static friction could be anywhere in a range from 0 up to a maximum amount. Okay? Anywhere in there. But kinetic friction always has to obey that formula, and that one value is much less than the maximum value for the static friction. And so that means you don't want your wheels to start sliding on the ice. Now those of you who grew up in Bozeman, you're on an incline, it's very icy, you're worried that you're not going to get up the incline. Do you put it in first gear and gun it? No. As soon as you gun it in first gear, your wheels are spinning, and that's all the friction you get. What you do is you put it in second gear, and you just ease on the gas, ease on it a little more, and you just work your way up to higher and higher values of static friction. Now with anti-lock brakes, what they do is the calipers grab the disc and try to stop the car. But right when it senses that the car is about to start sliding, it lets go and lets the wheel turn again. And then it tries again. And so it essentially just gets you clear up in this range, and then lets go, and then goes clear up in this range, and then lets go. And that's what the rat-a-tat-tat is. Now, let me see if I can make this more visual. Imagine that my fingers are the nooks and crannies of the road, and these fingers are the nooks and crannies of the bottom of the tire. Those nooks and crannies, when I'm dealing with static friction, aren't moving relative to each other. There's chemical bonds that are set up that we can only understand in Gaines Hall. Okay? Now, as I try to get out of this patch of ice, I push back with my wheels on the road. By third law, the road pushes back just as hard on my tire, on the nooks and crannies of my tire. Now, the harder I push on these bonds, the harder they push back to get me out of the ice. If I push too hard, I push so hard that I break all the fingers off and all I got is bloody stubs against bloody stubs. That's kinetic friction, okay? When I've got these bonds, these chemical bonds, I can get a bigger friction. When I get to the kinetic side, all I've got is just rough surfaces rubbing against rough surfaces. Okay? Now, those of you who aren't from here, at some point in your university career, you've got to go to the boiling river. Right, folks? As you go into Yellowstone Park from the north entrance, if you go about a mile, you'll see a sign that says you're at the 45th parallel. And at that sign, a little bit to the left, is a parking lot. And if you park there, there's a trail that goes a half mile to what's called the Boiling River. Geysers are gushing out into the Gardner River. And it's rocked out so that you can go in and enjoy, even in the wintertime, a nice hot bath. Now, if you get too close to the shore, you scald yourself. If you get a little farther out, you freeze to death. You can be toasty warm and have your hair just frozen. Now, many years ago, I took my younger kids there, and they had a blast until they got out, and then they were crying. But right outside of that parking lot, there's a very, very steep incline that goes up into Mammoth. And we were going up that incline in a blizzard, and the roads were just icy. And we were going up that, and suddenly in front of me there was a car that was stopped, just spinning and spinning and spinning. So I stopped and put on the emergency brake, and I waited. Wouldn't you know it, New Jersey plates. And eventually I just got so tired of waiting that I got out of the car, I went up, I knocked on the window, the guy opened up the car door, and I said, "Move over." And I just got in his car, I drove it to the top, my wife drove my car up. You have to help them, they don't know. They have no idea how to drive in snow.